This video, we're going to solve these questions here, these ODE. So what is the solutions? Okay. So we can rewrite here dy dx is equal to y squared minus x squared divided by 2xy. Okay, so we can further simplify this. We have 1 over 2 y divided by x minus 1 over 2 x divided by y. Okay, so we're going to do some substitutions here. Let's assume that the v is equal to y divided by x. So in this case, we can rewrite dy over dx is equal to 1 over 2v minus 1 over 2v. Okay, so now this v can be rewrite as the equal denominator. So the numerator will be v squared minus 1. Okay, so in this case, we're going to use the formula of this, which is we did the integrations of f of v minus v dv is equal to ln x plus c. So we're going to apply this formula to solve this homogeneous first ODE. So in this case, we need to recognize what is the fv, right? So what is the function of fv? In this case, the function of fv is equal to v squared minus 1 2v, right? So we're going to substitute this into the integrator. So we have 1 over fv, which is the v squared minus 1 2v, okay, minus v, and then we do the integration respect to dv. Okay, so now we can simplify this. Over here, we have flip this 2v to the numerators, and then we have minus v squared minus 1 dv, right? So now we can factor out the negative outside the integrator. Okay, so we have 2v become v squared plus 1 over dv. So we need to do this integrator. So to do this integrators, we're going to apply the formula here, which is we're going to integrate from this, let's say we're going to integrate f prime of x divided by fx dx. This is equal to the ln function of fx, right? So now, so the fx is the denominator. So the integrations of this, we get minus ln fx, which is v squared plus 1, right? So now we have this integrator. So the next is we're going to equal to this ln x plus c. Okay, so now we're going to rewrite this minus ln v squared plus 1 is equal to ln x plus c. Okay, so this can further simplify. On the right, this ln x plus c can be x plus c. Okay, now we can shift the negative to the right side. Here we have ln v squared plus 1 equal to minus ln xc. Okay, now in this case, what we need to do is we're going to multiply this with the exponential. We get rid of the ln functions. So here we have the v squared plus 1. So exponential minus ln xc is become 1 over xc. Okay, now we substitute back. Remember, we're going to assume that the v is equal to y divided by x. So here we're going to do the substitutions for v become y squared divided by x squared plus 1 is equal to 1 over xc. Okay, so now we can equal the denominator. So here become y squared plus x squared is equal to 1 over sc. So we can further simplify this by multiplying both equations with x squared. So we have this y squared plus x squared. This is equal to 1 over c x. Okay? So in this case, this 1 over c can be represented as another symbol, which is cx itself. So this is y squared plus x squared. So this is same to which answer that we have, which is equal to answer C. Now let us see question number 2. For the first order linear differential equations, what is the integrating factors? So to find the integrating factors, we need to rewrite this, whereby we're now going to turn the y prime coefficients equal to 1. So let me rewrite the questions here. We have this x y prime plus 4y is equal to x squared. So to change the coefficient y prime equal to 1, we divide the whole equations by x. So we have y prime plus 4x, y equal to x. So the integrating factors, we need to recognize in our equation here, the px is 4 divided by x, and our qx is equal to x. So integrating factors is equal to exponential integrate px dx. So here we have substitute px here, which is 4 over x dx. So the inverse of 1 over x is the ln x. So we have exponential 4 ln x. So here we have the x to the power of 4. So the answer for this is B. Okay, x to the power of 4. Equation number 3. Let yt be the solutions of these initial value problems for which value of a, when the time t goes to infinity, yt will goes to 0. So now we need to find what is the solutions of yt before we can find what is the a values. So this is just a characteristic equations. Okay, so we can rewrite this. We have this y2 prime plus 2y prime minus 3y equal to 0. And so we have our initial condition y of 0 equal a and y prime of 0 equal 3. So we convert this into a characteristic equation is r squared plus 2r minus 3 equal to 0. So we factor out this. We have r minus 1, r plus 3 equal to 0. So here we get 2r, r1 equal to 1, and r2 is equal to minus 3. So now we have two distinct roots. We can write the general solution for this, okay, which is y equal to c1 exponential t plus c2 exponential minus 3t. Okay. Now we're going to take the derivative of this. Y prime is equal to c1 exponential t, and here we have a minus 3c2 exponential minus 3t. Now, so we're going to use the initial conditions. Okay. So given initial condition, which is y of 0 equal to a, we're going to substitute into these equations. So that means y is a. Okay, I mean this y is a. And then so t equal to 0. So e0 is 1, we get c1. And then here we have plus c2. Okay. So that is our first initial conditions, a equal to c1 plus c2. And then we're going to substitute with our second initial condition, which is y prime of 0 is equal to 3. Okay, so we're going to substitute into this equation here. So in that case, we have y prime is 3. So c1 here is minus 3c2. Okay, so now we have these equations 1, And then we have this equation 2. Okay, so we can find C1 and C2. Let equation 1 minus equations 2. So here we have A minus 3. So C1 minus C1 is 0. So we have C2 minus 3C2, we get a positive 4C2. Okay, so we can rewrite this. This C2 is equal to A minus 3 divided by 4, right? Now from equations 1, we can rewrite the C1. What is the C1? C1 here is equal to A minus C2. So we can substitute this. What is the C1? By substituting C2. So C1 here is equal to A minus C2, A minus 3 divided by 4. So this is equivalent to 3A plus 3 divided by 4. Okay, so that is the C1 and C2. Now we're going to substitute back C1 and C2 into our equation general solutions. So we get the particular solution. So in our particular solutions, we have this y C1, which is 3A plus 3, 4 times exponential t. Okay, then plus C2, which is A minus 3 divided by 4, C2 exponential minus 3t. Okay, so this is our particular solutions. So now, let's assume that if the time t is goes to infinity, this function f of t must be equal to 0. Now, this solution yt consists of two terms. So in this case, meaning that if y is equal to 0, that means this term must be equal to 0 and this term must be equal to 0. So it can satisfy the equations y equal to 0. Now we see the first term over here. In the first term, so in the first terms, let's assume that we have this limit here of t goes to infinity. In this case, the exponential t, substitute with t goes to infinity, will be infinity, right? So for the first terms, this must be 0. That means 3a plus 3 divided by 4 must be equal to 0, right? So in that case, what we can see here, we have 3a plus 3 equal to 0. So we can find a is equal to minus 1. How about the second term? So the second term, let's say we're going to take the limit of t goes to infinity. So in this case, we can see exponential minus 3t. Okay, this will be go to 0, right? So that means we can find the solutions. That is, a is equal to minus 1. Then the yt go to 0 when the times is goes to infinity. So the answer for this is answer D. Let's see question number 4. A differential equation is considered to be ordinary if it has one independent variable. So question number 5. The solutions of the second order differential equations of this is, now let's see, so we're going to write this in terms of characteristic equations. So here we have y2 prime minus 2 y prime plus 14 y equal to 0. So in the characteristic equation, we can write as r squared minus 9r plus 14 equal to 0. So we factor this out. We have r minus 2 times r minus 7 is equal to 0. So we have a two distinct rule. Okay, r1 equal 2 and r2 is equal to 7. So our solution for this is a exponential 2x plus b exponential 7x. So I'll refer to the answers here, which is equivalent to the answer A.